am Desmond Edagise, and I welcome you to mathematics class today. Today we'll be looking at the theme, algebraic processes. And our topic for today is factorization. It promises to be a great one. Let's go on into our class. Now, in the course of our class today, we will learn what factorization is. We'll also learn how to factorize simple algebraic expressions. And finally, we'll learn how to factorize quadratic algebraic expressions. Factorization. The word factorization, what exactly does it mean? Factorization is broken into the word factors. So if we know what a factor is, then we'll know what factorization is. So what's a factor? Factors are numbers that you multiply to get a number. For example, if we were asked to find the factors of 15, the factors of 15 are the numbers that we must multiply together that will give us 15 for an answer. So 3 and 5 are therefore factors of 15. Now, some numbers have more than one way of being factored. Let's take a typical example, 12. 12 can be factored as 1 times 12, which will give us the result 12. 2 times 6 will also give us the result 12. And 3 and 4 will also give us the result 12. So the process of writing the number 12 into products of 3 and 4, or 2 and 6, or 1 and 12, that process is what we call factorization. Factorization aims to reduce something or our number to its basic building blocks. So again, 15 can be factored into the numbers that will multiply to give us that 15, and that's 3 and 5. The process of breaking down 15 into 3 and 5 is what we call factorization. Now, we've learned that numbers can be factorized. Also, algebraic expressions can also be factorized into one or more factors. For example, 9a plus 3z. Okay, that's an algebraic expression. This can be factorized into its products, 3 and all in bracket 3a plus z. 3 and 3a plus z are called the factors or the divisors of 9a plus 3z. 3 multiplied by 3a plus z would give us 3 multiplying 3a would give us 9a, and 3 also multiplying z would give us z. So we see that 3 and 3a plus z are the factors of our algebraic expression 9a plus 3z. Now there are steps that must be followed if we intend to factorize algebraic or simple algebraic expressions. Let's look at some of those steps. First, if necessary, okay, check to see if you need to simplify the expression given to us by expanding it first or grouping it in similar pairs. We use brackets when we group them in similar pairs. That makes it simplified enough for us to know what step next to take. Next, we'll look for the largest number that will divide into all the terms in our expression. There may be 1 or 2 numbers that can equally divide into that expression, but we look for the largest one, okay? Next, we also look for any common letters. We know that algebraic expressions are made up of numbers and letters, so we look for the common letters that are common to all the terms within the expressions. Now we multiply, okay, our largest number by that letter, and that gives us a common factor. So we have one common factor. Now, after we have taken out the common factor, whatever is left over, okay, is again multiplied together with our common factor, and that gives us the result of our factorization. There are two things to take note about factorizing. Factorizing an expression, okay, is also a way of simplifying it. And also, factorization is the reverse of expanding brackets. Let's take a typical example here. Okay. X plus 4 all in brackets, another bracket, x minus 1. This is an expression. When we expand it, we have this, x squared plus 3x minus 4. On the other hand, when we factorize this expression, we also get back this expression, which is in brackets. So factorization is the opposite of expansion, okay? So factorization is the reverse operation of expanding brackets. Now we'll take typical examples to better understand the steps that we just looked at. If we're asked to factorize 12a plus 8ab, following our steps, we said first find the largest number that divides into all our terms. All right? Every algebraic expression is made up of two or more terms. So we have a term here, 12 plus a is a term, and 8ab is another term. Terms are separated by operators. There we have an addition operator, plus. So we have 12a plus 8b. Now, the largest number that divides into this term and this term will be what? Let's see. If we take a look, 2 can divide into 12, okay, to give us 6. 2 can also divide into 8 to give us 4. But take note also, 4 can divide into 12 to give us 3, and divide into 8 to give us 2. So we have 2 and 4 as possible numbers that can divide into our terms, but we're interested in the largest number. So we take 4. 4 is the largest number that divides into each term. Also, we have a common letter. So we look at both terms. We see that A is a common letter in each of the terms. So we have A also. The steps we listed previously says we multiply our largest number by the common letter. So we have 4a, and that is our common factor. 4a is the common factor in our expression. Now, if 4a is taken away from 12a, what do we have left? 3. Also, if 4a is taken away from 8ab, what do we have left? 2b. So we say our common factor, again, is multiplied with the remaining term. Our remaining term is 3 plus 2b. We simply multiply 4a and 3 plus 2b, all in brackets, and that gives us, okay, our answer. Let's take a look at another example. Factorize 30mn minus 24mp. Again, we follow the same steps we listed earlier. Find the largest number that divides into each term. And that number is 6. 6 goes in 30 to give us 5. 6 goes in 24 to give us 4. A common letter in each term is also the letter M. So we have M. Multiply the largest number by that common letter, we have 6m. 6m is our common factor. All right, if we remove 6m from 30mn, what do we have left? We have 5n left. If we also remove 6m from 24mp, what do we have left? We have 4p. So this becomes our remaining term. 5n minus 4p is our remaining term. We put that in brackets to better organize it, and then we multiply the remaining term by our common factor. And that gives us the solution of our factorization. Okay? So let's look at more examples. Okay, these are a little more complex examples, so please take note. Now, if you are asked to factorize 2x, all in bracket 5a plus 2, minus 3y, all in bracket 5a plus 2. Quickly, we see that we have common things within our terms. Again, all of this, a little bit longer than usual, is a term. Again, all of this is another term. So we have two terms in our expression. Now, if we take a close look, we'll note that we have common factors in both terms. All right? So we don't need to go through all the stress that we've been going through. We already have common factors that we can easily pick out. What is that common factor? 5a plus 2, all in brackets, is common to both terms. So we simply have our common factor without going through all of the process of finding the largest number and then the common letter and multiplying them together. So in this case, we have a common factor which is already available for us, 5a plus 2. What we have left after we've taken away the common factor is what? 2x and 3y, okay? Of course, the operator between them is a minus, so we have 2x minus 3y. This is our remaining term after we've taken out our common factor. So to get our factorized expression, what do? We multiply common factor by remaining term. Common factor is 5a plus 2, all in brackets, multiplied by our remaining term, 2x minus 3y. And this becomes our factorized expression. All right, let's go on. Take a look at another example. Factorize a, all in bracket, 3u minus v plus a, all in bracket, u plus 2v. Okay? So this is not as easy as the one we just did. If we take a quick look, we'll see that there is no common term that we can pick out at once. So what do we do in this case? Remember the first step we talked about in solving factorization problems? We said, take a look if you may need to first of all multiply out the brackets, that is, expand the brackets, and if you also need to regroup them. All right, so in this case, we actually need to expand our expression first. So let's go ahead to expand. All right, to expand, we multiply whatever is outside of the bracket with everything within the bracket. Okay, so let's go ahead to do that. We have a, all in bracket, 3u minus v. So we have a multiplies 3u, 3au, minus a again multiplying v, av. In the other term, we have a multiplying u also to give us au, and a multiplying 2v to give us 2av. Our operator there is a plus. So we have as our expanded expression 3au minus av plus au plus 2av. All right, if we group the like terms together and carry out the operation, we'll have 3au and au, okay, are common. So we say 3au plus au, and that gives us 4au. Also, we have av and we have 2av. They are common also. So we carry out our operation on them together. We have minus av and then plus 2av. That gives us av. So we have a simplified expression, 4au plus av. We still have not factorized our expression. So we go ahead to factorize our expression the way that we know how to. So find the common letter in both terms. We have a term, 4au, and we have another term, av. What is the largest number that we divide into both terms? Okay, that number is 1. 1 can divide into basically any term. Okay, so in this case, we have 1. Also, our common letter is what? A. So we have our common factor, therefore, to be 1 times a, which is, of course, a. All right? The remaining term, therefore, if we take away a from 4au, will be what? 4u. And if we take away a from av, it will be v. So our remaining term is 4u plus v. We multiply that by the common factor a, and that gives us our factorized expression. So our factorized expression becomes a, all in bracket, 4u plus v. All right, we'll carry out also more examples, a little bit more complex again. Ax plus ay plus 3bx plus 3by. We've been asked to factorize this expression. How many terms do we have in this expression? Let's check. We have 1 term, 2 terms, 3 terms, and we have 4 terms. Okay? So in this case, we need to first group our expressions in similar pairs. Group your expression in similar pairs to make it, okay, easier for us to see, and then we'll know how to go about factorizing it. And what are the similar pairs? Okay, we have ax and ay. They both contain a, so they are similar pairs. We group them by putting brackets around them. Okay, we have our operator. And then we also group 3bx and 3by. We have 3 common between them. We have b common between them. So we group them again by creating brackets around them. Now that they are grouped, what do we have? 2 terms instead of the initial 4 terms. So now we've been able to reduce the terms from 4 terms to 2 terms. Now in each of the term, we can find our common factors. So what is common between ax and ay? A, of course, we take that out of the bracket, and then we leave a remaining term inside the bracket. So we have a all in bracket x plus y. In our other term here, what's common between, okay, them? 3b is common, so we take that out of the bracket and leave x and y within the brackets. So now we've been able to simplify our expression. At a glance, our common factor here in the 2 terms that we have is what? X plus y. So x plus y is our common factor. And our remaining factor is what? A and 3b with the operator plus. So we have a plus 3b as the remaining term. Multiply common factor with remaining term, would have x plus y, all in bracket, a plus 3b. And this becomes our factorized expression. Let's try one more example. Factorize 2b minus 5a plus 2b minus 5. Again, take note, we have how many terms? 1, 2, 3, 4. We have 4 terms. Again, to simplify this expression, to make it easy for us to work, what do? We group our expressions in similar pairs first. So to simplify our expression, what do? We group the similar pairs in brackets. Let's look at our expression. We have 2ab. We also have something similar, 2b. Okay, we can group that together, and to group them together, we make use of our brackets around them. Also, we have 5a and 5. So we have 5 in common. Therefore, they are similar pairs. We group them also by putting that bracket around them. Remember, our operator here is a minus that is in front of our 5a. So we have minus there. So now that we've grouped them, we can look and see that we have 2 terms instead of the initial 4 terms. Okay? We are just trying to simplify our expression in order to factorize it. Again, within our term here, we have some common factors. And we have 2 common between them. We have b common between them. So we take the b out, and whatever is left in our term is what? A plus 1. So we have 2b all in bracket a plus 1. In our second term, we do the same thing. 5 is common. We take 5 out of the bracket, and we leave the remnant a plus 1. So we have 5 all in bracket a plus 1. So again, if we look at our terms that have been simplified, we have common factors a plus 1. A plus 1 is common here, is also present here. So our common factor is a plus 1. The remaining term is 2b minus 5. So we'll put that in bracket, 2b minus 5. Our factorized expression is the multiplication of our common factor with the remaining term. So we have a plus 1, all in brackets, 2b minus 5. And this is our factorized expression. So far, we've been able to work on simple algebraic expressions. Now, we'll see how to factorize quadratic algebraic expressions. So what's a quadratic expression? A quadratic expression has a variable that is the unknown, okay, usually represented by letters, maybe X, Y, A, B, or something, our unknown is always raised to the power 2. So that's the difference between the quadratic expressions and the simple algebraic expressions that we worked on previously. Previously, none of those expressions had our variable raised to the power 2. So far, we'll be dealing with quadratic expressions that have variable that are raised to the power of 2. Now, take note that quadratic algebraic expressions, okay, may have 2 or 3 terms. In this class, we'll be dealing with quadratic expressions that have 2 terms and 3 terms. Now, for quadratic expressions that have 2 terms, we have a normal case, okay, which, for instance, z squared plus 5z. That's just 2 terms, okay? Z squared plus 5z. When we have situations like this, where we have, of course, one of our variable raised to the power of 2, and then the other one is a mixture of number and a letter, okay? There are steps that we should follow. And those steps are the same steps that we followed when we were solving or factorizing the simple algebraic expressions from steps 2 to 4, okay? We said in step 2, look for the largest number that divides into each of the term, okay? And then we said also look for the common letter. We said multiply. If this is 0.2, this is 0.3, this is 0.4, multiply 2.2 and 3 together to get a common factor. And finally, the 5th step, we said multiply that common factor by the remaining terms. Multiplied by remaining terms. Okay, so it's the same steps basically that we followed for the simple algebraic expressions that will follow for cases of 2 terms in quadratic expressions, okay? Also, for cases still of 2 terms, where we have the difference of 2 perfect squares, for example, b squared minus 1. For such cases, notice that in this other case here, we had our variable raised to the power 2, and then we had, in the other term, a mixture of numbers and letters. But in this case, we have our variable raised to the power 2, and then on the other term, we have just numbers. So there are 2 separate cases. Now, for this case, there are 2 steps to follow, 2 simple steps. First, find the square terms that will each equal our expression. Square terms, that is terms that we can raise to the power 2, that will each also equal our initial expression. So in this case, we have b squared minus 1. 1 is same as 1 squared, okay? Whenever 1 is raised to any power, it remains the same 1. So in this case, just for an example, we have b squared minus 1 squared. It's still the same as b squared minus 1. And then what do? You rewrite that expression as this, okay? They are raised to the power 2, and therefore, we expand them, making use of brackets. So we have b minus 1 in one term, and then we have b plus 1. The powers are positive and negative because when they multiply out, they will give us our initial negative power. Okay? So we expand that by creating two terms in brackets, b minus 1, all in brackets, b plus 1. This will also multiply out if we were to do a reverse operation to give us back, okay, our initial term, b squared minus 1 squared. So these are the steps. Next, we'll do some examples to see how to put these steps into work. All right, so let's take first example. If you were asked to factorize m squared minus 7m, okay, we said for such occasions, just follow the initial steps that we learned about. Find the largest number that divides into all the terms. That number is 1. Okay, we have 1 in front of m squared. We also have 1 in front of 7m because 1 will multiply each term to give us the same thing as they are. So we can say our largest number basically is 1. And we have a common letter also. M is common for both terms. So we say our common letter is m. Our common factor, therefore, is 1 times m, which is m. Now, if we take m away from our first term here, what do we have? We have 1m left, minus. If we take m away from this term here, what do we have? 7. So we multiply, this is our remaining term. Multiply our remaining term with our common factor. We have m multiplied by all in bracket m minus 7. And this becomes our factorized expression. Let's take another example. 12x squared plus 30xy. Again, we follow our steps. Find the largest number that divides into all the terms. We have one term here and we have another term. Our numbers there are 12 and 30. 2 can divide into 12, give us 6. 2 can divide into 30, give us 5. 3 can also divide into 12, okay, to give us 4. 3 divides into 30, it gives us 10. 6 can divide into 12 to give us 2, and 6 in 30 to give us 5. So basically, we take the largest number. So we have 2, 3, and 6 that can divide into both terms. But what we need is the largest number. So 6 is our largest number. Again, we take note of the common letter in both terms. Take a look. X is common. So x is common. We multiply our largest number by the common letter to give us the common factor, 6x. So we have 6x as our common factor. Now, if we take away 6x from the first term here, what do we have left? 12 divided by 6 is 2. X squared divided by x is x. So we have 2x left. Plus, again, 6x. 30 divided by 6 is 5. Okay. xy divided by x cancels out, we have y left. So this is the remaining term, the remnant, the remaining term. Okay, to get our factorized expression, we multiply common factor by remaining term. Common factor is 6x. Remaining term is 2x plus 5y. And so we have our factorized expression as 6x all in bracket 2x plus 5y. So far, I hope we've been following. We'll take some more examples so that we can become proficient in factorizing algebraic expressions. Let's take this example. Factorize x squared minus 100. Okay, so this is an example of the second situation that we talked about where we have perfect squares. Okay, we follow two very simple steps. Okay, we said first, find square terms that will equal our equation. Okay, our equation is what? X squared minus 100. Okay, we have two terms. We have x squared and we have 100. So we are looking for square terms that will equal this equation. We'll find terms, a square term that will equal x squared and another term that will equal 100. Okay, so our x squared, of course, remains x squared. And then our 100, okay, we'll find a term that when we square it, gives us this 100. Now, the terms, okay, that will equal our x squared here is same as x squared, so we leave that. But for our second term, 100, we'll find a term that when squared will give us 100. And that is 10. When 10 is squared, okay, it gives you 100. So what we have our equation is rewritten as x squared minus 10 squared. X squared minus 10 squared. Each term is squared. We can rewrite that, okay, by expanding it. So when we expand our expression here, what do? We regroup them in two places because they are both raised to the power of 2. So we have x and 10, and in the other bracket we have also x and 10. But the power here, okay, is a negative power. So we make use of our powers, plus in one of the brackets and a minus in the other bracket, because the plus and minus, of course, will multiply out to give us our negative power. So we have x plus 10 brackets, x minus 10 also in brackets as a factorized expression. Let's take another quick example. 4x squared minus 9. We've been asked to factorize 4x squared minus 9. So we said step 1, find square terms that equal our equation. We have 4x squared as our first term, and we have 9 as the other term. So we look for terms that, when it is squared, will equal what is our term here. We have 4x squared as that term. 4, of course, can be broken to be 2 squared. So we have something like this, 2 squared, and of course our x squared is still squared, which can be rewritten as 2x all in bracket squared. So we have 2x squared for our first term. The second term is 9, okay? We'll find the square term that when raised to the power 2 will also equal this term. 3 raised to the power 2 will give us the term. So we have 2x squared minus 3 squared. This is our new expression, okay? Since they are both raised to the power of 2, okay, we can expand this expression to be what? 2x, and then we have our 3 in one of the brackets. Also, we have 2x, then we have our 3 also in the other bracket. So we have 2 brackets. But our power here is a negative power. Therefore, our powers here must multiply out to give us negative. So we have a negative power in one of our brackets and a positive one in the other bracket. 2x minus 3, all in brackets, 2x plus 3 becomes our factorized expression. Now we'll deal with quadratic expressions that have 3 terms. So far we've dealt with quadratic expressions that have 2 terms. Now we'll look at quadratic expressions that have 3 terms. To factorize such expressions, take for instance x squared minus 2x minus 15. How many terms do we have? 1, 2, 3. We have 3 terms. X squared minus 2x minus 15. What step do we take first? We find 2 numbers. Those numbers must satisfy 2 rules. 1, they must multiply to give us the constant term in our expression. The constant term is that term that does not have, okay, any letter attached to it. So 15 does not have a letter attached to it. 2x has a letter, x squared, of course, has a letter. So our constant term there is 15. Find 2 numbers that multiply to give us 15. And those same numbers, when they are added together, should give us the number in front of x. That number is usually called a coefficient, okay? So they must multiply to give us 15 and then add to give us 2. So your assignment is to find such a unique pair of numbers. When we have them, for this case, we have those numbers as what? Minus 5 and 3. Minus 5 times 3 will give us what? Minus 15. Okay? So we have minus 15 as the term that is our constant term. And we said when added, it should also give us a number in front of x, that is our coefficient of x. So we have minus 5 plus 3, which gives us minus 2. So it satisfies our condition. Minus 5 and 3 satisfies our condition. Okay, so they are factors of 15. When added, will also give us minus 2. All right, so we go ahead to rewrite our expression. We rewrite it. Okay, so instead of saying minus 2x, when we know that minus 5x plus 3x, will also give us minus 2x, we can rewrite that to be x squared minus 5x plus 3x minus 15. Minus 5x plus 3x is the same as minus 2x. So we're just replacing minus 2x with minus 5x plus 3x. Okay, so we rewrite our initial expression as this: x squared minus 5x plus 3x minus 15. And then we go ahead to collect and group like terms together. So in this case, we just regroup. We say x squared minus 5x, all in brackets. Grouping involves our bracket, okay? Plus, we have 3x minus 15. Okay? So we have two terms instead of the initial 1, 2, 3, 4 terms. From 4 terms, we have just 2 terms now. And here we can easily go ahead, okay, to regroup them further. Okay, so we collect the like terms. Within this first term, we have what? X is a common, okay, letter. We take x out. What do we have left? We have x, and then we have minus 5. Plus, in this case also, 3 is common. 3 can go in 15, and 3 can go in itself. So we have 3. We'll be left with what? X minus what? 5. 3 times 5 is 15. So take note, we have x minus 5, and we have x minus 5. In both terms, that becomes our common factor. So we have a common factor, x minus 5. And whatever is left, and that is x plus 3, becomes our remaining term. So we have a common factor and a remaining term. To factorize, we simply multiply them together. We have x minus 5, all in brackets, multiplied by x plus 3, also all in bracket. And this becomes our factorized term. So that's, or these are the steps to follow when we factorize algebraic expressions that have 3 terms. Okay? So let's take some examples. If you were asked to factorize a squared minus 6a minus 27. Step 1, find 2 numbers that multiply to give a constant term. Our constant term there is what? Minus 27. So we'll find 2 numbers that when we multiply them will give us minus 27. And when we add them, it will give us the coefficient of a. That is the number in front of our letter a, okay, which is minus 6. All right, so 2 numbers when multiplied will give us minus 27. When added, will give us minus 6. What numbers are these? They are what? Minus 9 and 3. Minus 9 times 3 is what? Minus 27. That's correct. Also, minus 9 plus 3 is what? Minus 6. Also correct. So it satisfies, okay, our situation. So we rewrite our expression, therefore, as a squared minus 9a plus 3a minus 27. Remember that minus 9a plus 3a is same as minus 6a, because minus 9a plus 3a is minus 6a. Okay, so we're simply replacing this with this. So we have a squared minus 9a plus 3a minus 27. So next, we collect and then we group our like terms. So we have a squared minus 9a. We group them, okay, by placing a bracket around that, plus 3a minus 27. We also group that by making use of our bracket. And of course, we can further simplify this by taking out our common, okay, terms. We have a there. A is common in that term. We have a left minus 9 is also left. Okay? In the same way, in our term here, we have 3. 3 is common. We have a remaining, and then we have 9 remaining. So if we take a quick look here, we'll find that we have a common factor already. A minus 9 is common. A minus 9 is common for both terms. So we have our common factor, a minus 9. And then we have our leftover term, which is a plus 3. So that is our leftover term. The factorized expression becomes the multiplication of our common factor by our leftover term. So we have a minus 9, all in bracket, multiplied by a plus 3. And that is our factorized expression. Let's take another example. Factorize y squared plus 7y plus 10. Okay, again, we follow the same process. We find two numbers that when we multiply them should give us plus 10. And when we add them, should give us plus 7. Those numbers are 2 and 5. 2 times 5 will give us 10. 2 plus 5 will give us 7. So we write our expressions, therefore, as y squared plus 2y plus 5y plus 10. And then we can easily collect and regroup them. Okay, we have y squared plus 2y. We group that by putting a bracket around them, plus 5y plus 10. Okay, that's another group. We can go ahead to simplify that further as y is common. Take y out. Then we have y left. And then we have in 2y also, 2 is left. Plus 5 is also common within the term. So we have y plus 2. Again, notice we have this as our common term. Y plus 2 is common in each, okay, of those terms in the expression. So y plus 2 is our common term. And then whatever we have left over is what? Y and plus 5. So we have y plus 5. Okay? Our factorized expression is the multiplication of our common term and leftover term. So we have y plus 2 all in bracket multiplied by y plus 5 also in bracket. This becomes our factorized expression. Wow, it's been quite an exciting class. But so far, we've come to the end of our class for today. Let's take a quick summary to see what we learned. We learned about factorization, but we said factorization is all about finding factors. And we said, what are factors? We said factors are numbers that you multiply to get another number. We use an example of 12. We said when 3 and 4 is multiplied together to give us 12. But also 1 and 12 multiplied together can also give us 12. And we said 6 and 2 multiplied together can also give us 12. So we have different factors. 3 and 4 is one factor. 2 and 6 is another pair of factors. And 1 and 12 also another pair of factors. So factorization is simply finding the building blocks of a thing. Okay, we said aside from numbers, okay, algebraic expressions can also be factorized into factors. For instance, we said 9a plus 3z can be written, okay, as their products. And their products are what? 3 and 3a plus z. Because when we multiply 3 times 3a plus z, we would have 3 multiplied 3a gives us 9a, and 3 multiplied z will give us 3z. So again, 3 and 3a plus z are the factors or the products of our algebraic expression 9a plus 3z. We learned how to factorize simple algebraic expressions and also quadratic algebraic expressions. Before we go, however, to confirm that, of course, we've learned how to carry out factorization, we'll take two quick questions. So question 1, factorize 4x squared minus 81. 4x squared minus 81. This is a case of the perfect square situation. And remember the steps? We said find two terms that when squared will give us our initial equation. So we have two terms, 4x squared, and then we have 81, okay? So if we break down 4, we'd have 2 raised to the power 2 as a component, and then we also have our x squared. 9 can be raised to the power 2 also. This can be rewritten as 2x, all of that raised to the power 2, minus 9 raised to the power 2. We said since they are both squared, okay, it means that we can expand them, okay, in 2 places or as 2 groups. We can expand them as 2 groups. So we have 2x and 9 in one group, all in bracket, 2x again, and 9 in the other group. And we said because our operator there is a minus, it means that each operator in each bracket must multiply out to give us that minus. So we have one should be negative and one should be positive, because a minus multiplied by a minus will give us a plus, and that would not be from our initial equation. The only way we can get our initial operator is to have one minus in one group and a plus in our other group. So our factorized expression becomes 2x minus 9, all in bracket 2x plus 9. So let's see which of our options is our correct answer. Is it A, B, C, or D? Our correct answer is option C. 2x minus 9 all in bracket 2x plus 9. Okay, so we'll go ahead to solve our last question for today. X squared minus 9x plus 14. Factorize that. Factorize x squared minus 9x plus 14. Okay, for such situations, we said find two numbers that, when multiplied, should give us our constant term. The constant term is a term that does not have a variable attached to it. That two numbers, when added, should also give us the numbers in front of our x, that is the coefficient of x, which is minus 9. So our two numbers should multiply out to give us plus 14, and then add up to give us minus 9. What numbers are these? Okay? Think hard, think hard, think hard. Let's take 7 and 2. 7 and 2 would multiply to give us 14. Added also to give us 9, okay? But then we need to know how to place our powers, because we have minus 9 and not just 9. So we have minus 7 and minus 2. Minus 7 times minus 2 will give us plus 14. And then plus minus 2 will give us minus 9. So this fits, okay, into the numbers that we seek. And then we go ahead to rewrite our expression as x squared minus 7x minus 2x plus 14. We said minus 7x minus 2x is simply replacing minus 9x, because they will also work out to give us the same value. Okay? Now that we've done this, we said regroup. So we can regroup by placing a bracket around that term, minus 2x plus 14. That's another group. So instead of the 4 initial terms, we have just 2 terms left. Then we can go ahead to bring out our common term here. X is common. So we have x left, and then we have 7 left. In our other term, we also have 2 is common. So we have x, and then we have 7 also left. So we can say that our factorized expression, of course, is the multiplication of our common term. The common term in our expression there is x minus 7 multiplied by the remaining term. The remaining term is what? X and then minus 2. So we have x minus 7, x minus 2. And that becomes our factorized expression. Let's see which of our options here has that correct answer. Is it A, B, C, or D? Option D is correct. X minus 7 not in bracket, x minus 2 is the factorized expression. And so we've come to the end of our very interesting class for today. I'm sure you learned so much, but remember, in order to retain all that you've learned, you've got to practice, practice, practice. Till I see you in the very next class, I'm Desmond Edagese. Bye-bye for now.
If you enjoyed this video, hit the like button, drop a comment, and subscribe to our channel. You can also turn on notifications to stay updated on new videos on this channel. This Brain Friend video was brought to you by Synforest. For more of these amazing e-learning videos, get your copy of Brain Friend. With more than 1,000 e-learning videos, over 74,000 test items in more than 40 subjects, a career counseling guide, and many other amazing features, BrainFriend remains your foremost e-learning and exam preparatory software. BrainFriend. Learn better, make excellent grades.